Hello friends, welcome back to the bench. Today we have a MaxiTPMS meter which has been treated with 12 volts. So this is the charger for it, and it produces 6 volts, 300 milliamps, and since this is our plug, it is absolutely reasonable to expect that 12 volts can be applied here, because typically, the 12 volt chargers come with this particular plug, so you would expect that the device should be able to handle that, which would be as simple as just putting a voltage regulator on it, and that would solve the problem. There are some measures here, like almost a full bridge rectifier, so you can mix up the polarity, but if you over voltage it, it dies. So let's take a look. This is our charging port. All right. Let's get some pointy thingy. That's our charging port. We have plenty of cups, no shorts. What we are looking for are shorts, because that's what we expect if the higher voltage was applied. We have these diodes over here, so I expect that even if we reverse polarity, it will still, well, at least it won't be broken because of that. Some caps, another diode, big coil. We have a little fuse over here. The fuse is okay. And we have a SD-RAM chip. This is the equivalent of 32 megabytes of RAM. I'm saying equivalent because this is 4 million times 16-bit values, so you can think of it as 32 megabytes of actual storage. And all that is controlled by Autel microcontroller, right? And that goes to our, run out of room. That goes to our OBD connector. We have some fuses over here, which I don't see right now, but I remember there were some. Maybe they're on the other side. We have two. I'm not sure if these are antennae or these are just balances for this. I'm not sure, but it does utilize the radio communication, obviously, to connect with the sensor. Here's one fuse. It is good, and that's pretty much what we have. Now, I have received the pictures of this device before I received the device, so I already knew that this element is burnt. Let's take a closer look. Right, it definitely dissipated a lot of power. So this is burned, but we can no longer read what it is. Luckily, Pavel, which is the owner of this device, took pictures of the device that wasn't broken, so we can read the markings on this. And what it is a voltage detector IC. It is relatively simple. This is typical application. So we connect VDD, and the V out goes low if the VDD reaches a certain level, and that level is from 1.9 to 4.6 volts. This particular one, based on the markings, is 3.5 volts. This is the equivalent diagram. right? Nothing special here. Our NPN transistor just jumps to ground, output to ground. That's why we have a pull-up resistor and and a shunt capacitor. So nothing special here. This component is available on Mauser. We have it here. And now, what does it do? Here's the dilemma I have. Based on the markings, the component I ordered is the replacement for this one. But based on the visual inspection of the application of this element here, it seems a bit less likely. So this pin should be, according to data sheet, should be NC. Right over here. Should be NC. It is not. It is connected to something. It goes to this via over here. This is our input, so our voltage detection. It is supplied through a voltage divider. So this kind of makes sense. It could be. And this is our output. So this goes low. And this goes low when the voltage reaches the level it needs to reach. Which pulls, I assume this is VSS of the memory. So I expect that this needs to go low for the memory to turn on or to reset. This is supposed to be ground, but this goes to the coil, right? And not exactly to ground. So either this is the application of this chip that I'm not familiar with, or at least the data sheet doesn't explain this application. And this is very much possible. Or this is in fact different component, and we're gonna replace it with non-equivalent. But until we get there, let's do measurements. I obviously already measured everything and diagnosed it as well as I could. But if we connect between input and output, we get 500 ohms, right? So that is not what we expect. So this transistor on the output is now changed into a resistor, which transistors sometimes do. Between these two, I get 10K, which is okay. And between output and ground, I'm getting still 500. What is interesting, and we'll know once I remove this chip, but this resistor, according to its markings, should be 1.3K, and it is 10 ohms over here right now. Could it be that the resistor reduced its resistance? It is possible. It's in my experience, it's rather unlikely. Normally, when I see the resistors burnt or and otherwise faulty, they just go open, or the resistance goes like way high. But it is possible that the resistor catches fault in a way where it just reduces resistance. It is more common with the transistors, or at least in my experience, but it is possible. But we'll know that once we take this guy out of the circuit, because right now this guy is going to be messing with our measurements here. The other possibility why this resistor has such low resistance is that this chip is faulty, meaning it just shorted out because it got 12 volts. If that be the case, there's nothing we can do, because I can just replace this one, because I need binary to upload to it. There's no way I'm gonna find binary, and I'm pretty sure there's no way to take off this chip from the working device and read the binary from it. I would think that would not be possible, but maybe I'm wrong. This chip available. I actually ordered one from China, so it'll still be a while before it gets here. But there's no problem replacing this one, because this is just SD-RAM. There is no code in it. So basically, if our 12 volts made it to the supply pins of this chip, we're done. There's nothing else we can do. But now we did the measurement, so we know that this component is not exactly dead shorted, but it's acting like a resistor. Let's connect the power. And if I connect power, see that blob lighting up and disappearing. Light up. 28.7 degrees, right? And we are consuming 13 milliamps at 5 volts. So this would not be visible. You would not detect it heating up with your finger, because it's just a few degrees above the room temperature. So without thermal camera, it would be difficult to spot. But since it's already burned, we already concluded in the visual inspection that this is our suspect. Now the question is, so we are shorting here, right? So if this went short as soon as 12 volts was applied, and it was enough there was not enough current for this to be unable to drop the voltage to safe levels, we're good. Meaning the logic should not be damaged because of that. However, if there was enough current that this little guy couldn't pull it enough to the ground to reduce the voltage, and the higher voltage went to the logic, well, in that case we're done. But let's for now let's proceed as that didn't happen, and check if we're charging the battery. $159 milliamps, 0.7 watts. And so we're charging the battery. So battery charging circuitry is okay, or at least based on this this little experiment. This is lithium-ion battery, 3.7 volts probably. Should be fine. Okay, so now let's keep this so I don't lose it, because I don't know what's on that SD card. Maybe it's some proprietary software on there, something like that. Antennas are kind of close, so let's get rid of it. And for this job, I'm gonna use my bent nozzle. First time I'm using this one. I just got it recently. It's a lot smaller than the one I use for IC608 resoldering, so that's why I haven't used it yet. But now I need much smaller area, so I'm gonna use a little more air restriction and at the angle. So let's see how that works. Okay, now the question is, what are we gonna see? Let's get the thermal camera too. Okay, now we have 0. So the short is relieved. The short is gone, but does it mean the device is working now? It is dead. Yeah, so now I'm getting 1.3 over here. Yeah. So this is good. So the chip was 1.3 over here. Chip was damaged. 22K over here. So here's the issue. we no longer have a short. So that was our source of our fault. It's gone now, but the meter is still not turning on. When I press the power button, I do draw about 1/100th of an amp, 1 milliamp. So that's 1,000th, whatever. So it is being prompted to boot, right? The prompt to boot goes to our microcontroller and it takes over the rest. It is not booting, so my conclusion is that the microcontroller is fried or somehow faulty after the high voltage, and it doesn't prompt the device to boot. There is also another possibility, because I'm not getting enough voltage over here. I'm getting 300 millivolts, but that is enough for this chip to turn on according to specs. So I wouldn't expect that's an issue, but it could be. But how do we find, well, if the voltage is low, that means there is a short somewhere. How do we find shorts? We apply voltage, but nothing is heating up. I don't see any signature, any heat signature that would be consistent with short on the thermal image. So I'll probably give it one more look later on, but at this point I deem there's no fix and suspected damaged microcontroller faulty, which means we cannot replace it unless we had another exact same device, right? Damaged somehow differently to just swap them. But you never know. These devices, they might look the same on the outside, but actually the specs are different and the binary is slightly different because there's slight difference in configuration or something, different components used, that kind of stuff. So it's never a, never a given. Did I check these? Let's just quickly check these fuses. I do believe I checked them all. And the fuses are good. And these fuses, they're close to OBD, so they're probably, yeah, there's unfortunately nothing more I can do with this. I mean, I will probably look at it again. There's also a possibility that this chip is not what we had, but it's very unlikely. I would say it's unlikely. That's what the spec said. That's the element. It makes sense. Well, I'll look into that again. But at the moment, this is no fix. Sorry about that. But you know what they say. You can't win them all, right? Alright, so this goes just for the bench fee. No other charges, because no fix. That is too bad, but I hope you at least found this interesting to see what's inside this meter. This meter is like $300-400. So surprisingly, there's no like protection from over voltage, which sucks. It's a good device. Alrighty, thank you guys very much for watching. and I shall see you in the next one.